last night. You sent that TikTok and it was.
I'm sorry. I was crying.
Yeah. Alright,
it's time. Let's do it.
Crying on FaceTime last night.
Oh, yeah.
And I soothed him with my singing.
So, A, B, and D, E are parallel. Here we go.
Mark Cypher's
I am so upset.
If you're talking right now, shut up.
Shush.
These two lines are parallel. A, B, C, and B, D, E, C. We need to prove that they are similar. Now, we know that we've got a couple things to use to prove things similar. What are you asking about?
A. Alcohol.
It's okay. Yep. All right.
Not actually.
So we know that we have
Share an
angle similarity. Very good. We have side similarity, and we also have side similarity. Now remember, when we talk about sides, we want them to not be congruent. We want them to be proportional, meaning that they relate somehow, right? By double, half, triple, something like that. And unless we have that information, we're not allowed to use this stuff. Now that stuff is kind of hard to acquire, which is why AA is usually what we end up using. In this diagram, we have no information about the sides, so there's no way to get any of this stuff. So we're going to be using AA. What do you see?
Shared angle.
Wonderful. Thank you for raising your hand, Cheyenne. You were going to say it too. All right, so that angle shared by the top and the bottom triangle. Two triangles that I'm interested in, right? Top and bottom, I should say, right?
So
This is not a triangle.
Just shared angle.
So we have a shared angle, yep. By shared angle. Triangle, or I'm sorry, angle DCE we'll call it, is congruent to angle ACB. Could you just call it angle C? Sure. Pretty good. Sure thing, bud. All right. Now we got parallels. What can we get from that, Cheyenne? CED and CBA. So these wouldn't be alternate interior, because if you look, what we have is two transversals cut by this, I'm sorry, two parallels cut by this transversal, right? And notice that both of these are on the same side of the transversal, yeah? CED and CAB? Okay, so that's not going to be it either, and the reason for that is we have, to get this angle, notice we're looking at two different transversals to do that. So focus on one at a time. Alternate interior is when you have something like this. And that's because, look, they're on alternate sides of the transversal, right? Opposite sides, left side, right side. And they're in the interior. They're in between, in the inside of the parallel lines, right? So we're not going to have any of that here. Because if you look, we've got angles here and angles there. What are we going to have?
Corresponding.
Corresponding. Mm-hmm. Yep. This is just regular old corresponding. So corresponding angles is when you have something like this. Assuming these two are parallel, you'd have this and this be the same.
My AirPod just keep.
Right? So we have these two angles. Now, could we get that from the other side as well?
Yes.
Sure, but we don't need it because 2A's is all we need to get the job done. So I'm going to say by cap, corresponding angles postulate, I know that angle CED is congruent to angle CBA. And now that I've mentioned both angles, I can use both angles in AA, right? By AA similarity, triangle ABC, that's the big old triangle, is similar to, let's match up the parts. Well, A on the big triangle is this angle, it's the unknown angle, the one we haven't messed with. So it must go with D on the small triangle. And B is orange, so it's going to go with E on the small triangle. And then, of course, they share C. And look, that's exactly what they wanted. Good on Mr. Mac. What?
How do you know how it's ABC?
I chose ABC because I did alphabetical order. You could switch the order. So, Shelby, if you had written BAC here, then you would have written over here, well, B goes with E, right? So you would have written E. A goes with D, and then C goes with itself. You see how this guy kind of locks this one in? Right? What you choose here locks that in. You can choose whatever you want here. I almost always do alphabetical order for the first one, though. That way you guys don't get too confused when I do things, and it's consistent. So I almost always go with this thing. Also, isn't that what they wanted? So if they want A, B, C, I'd prefer you to not write BAC. Cool. 2. Okie dokie. BD and AE are line segments, is what it's saying. So there's no break here. This doesn't bend down or anything. There's no slight bend. We know that B and E are the same angle. Do you have a question or do you have something to tell me about? I'm not ready for suggestions just yet, but I will come back to you if that's what you want me to do. These two angles are congruent, right? That's what this means. And we're going to get these segments. Well, since we only have two triangles here, I would assume these segments are a part of these two triangles. If you check, they are AB and BC, CE, and DE, right? So these are the two triangles I need to get similar in order to talk about their parts. What do you see, Bailey? Vertical angles here and here. Now, on the list of things that are true but not necessarily helpful, vertical angles, LPT, and shared angles are probably at the top, right? Those are the things that you're going to see a bajillion of them everywhere. There's going to be lots of shared angles, there's going to be lots of vertical angles, there's going to be lots of linear pairs, right? The question is, do you need them? And in this case, these two triangles are what I'm interested in. And if we did vertical angles, we'd get these two angles. Both of those angles belong to my triangles I'm interested in. So vertical angles here would be helpful, right? Again, if you see vertical angles, ask yourself, does it actually help me get anything? And if it doesn't, wait on it a little bit, right? Because it's going to fill up your diagram very quickly. But in this case, we do need it. So we're going to say, by vertical angles theorem, angle, can't call it C, so I'll call it ACB, congruent to DCE. And now I have enough information to prove the triangle similar, right? By double A similarity. Triangle, let's do ABC for the left side one. Similar to triangle, well, A is going to go with D, right? B will go with E, and C will go with itself. Awesome. Are we done?
No.
No, it's not what they wanted, right? They wanted us to talk about the parts. Now, when we talk about the parts of a triangle being similar and match up with letters, once we have something like this, right? And now that we have that, we can talk about CSP, right? So CCP of similar triangles, corresponding similar parts. So by the corresponding similar parts, we know that corresponding parts will be similar. Corresponding means same relative location. So if you look, AB and DC, or DE are both corresponding. They're in the first and second spot, right? So I would say that AB must relate to DE the same way that BC being in the second and third. What's second and third on the other triangle?
EC.
EC, very good. How do you guys like the new big screen?
I can see that.
Is that better?
Yes.
A lot better? Okay, good.
I thought it was always like
I've been thinking for a while that it needed to be bigger. In fact, I can even shrink this down some more now.
Well, I like to be able to see you, like, when I look up in the word.
Like you like being able to see me
Yeah.
on there?
Yeah.
Wow. Okay, interesting.
If that
And
makes
then,
sense.
and then first and third, yeah, it makes sense. I don't know why you want to do that, but I understand what you're saying. AC is this, so it's going to go with DC. Now, which parts do I care about? I care about AB and BC. There's AB, there's BC. And I care about CE or EC, right? And DE.
Take out the last one.
So I don't care about this guy. So I'm just going to work with these two. You don't need to rewrite this if you don't want to. I'm just doing it for clarity. In fact, I'll write CE instead of EC. What's the question?
Do you have to write by transiting?
Nope. We're going to take that as given. Like when I have a 90-degree angle here, by LPT would get me the other 90, right? But that's last semester stuff. Eventually we have to assume a basic level of competency, right? So we're going to move the stuff around by multiplication. When we do that, here's what happens, right? If I want to move CE over, I'm going to times by CE, right? Because that's how you get rid of division. Now the reason this cancels or goes away is because really what we have here is CE divided by CE, which is 1, right? CE divided by CE is 1. And so 1 times BC is just BC. And then over here, it doesn't go away because CE divided by DE is just a thing. And then we times it by AB. Multiplication happens in the top. So we get this. Whoops. Cool. Now to move over to the DE, we do same thing, right? And we get CE times AB equals BC times DE. So I goofed up this. I didn't change this on the retake, so cross that out. My bad. let's write AB times CE, my bad, equals BC times DE. I think you guys can tell I've used the worksheet, but just changed what they give you or what the letters are. This one I did not change,
Wait,
my
it's
bad.
AB times what?
AB times CE and BC times DE. So basically what we got, right? Now why am I allowed to switch these two around? Commutative property, right? Again, do you need to write that? No. But 2 times 3 is the same thing as 3 times 2. So CE times AB should be the same thing as AB times CE. This is actually not true for everything, but it is true as long as we're using the basic rules of algebra. Cool. Just like geometry, not everybody's algebra is the same. But the algebra we operate under, that's how it works. 3. How do we feel about the first two? Feeling great, feeling frosty? Fantastic. All right, this one. Measure of angle C and DEA are both 90. So that's a 90. That's a 90. What that means. And again, we want to relate the parts. Well, which parts? AD and BC. We want to relate AB and DE. Cool, so these are the two triangles I got to get similar, right? The only two triangles in the diagram, the huge one and the smaller one. So, what do you see? Go ahead. Yep, angle A is shared for both. The small triangle uses A, and the huge triangle uses A, right? The whole thing. Not part of A, not half of A, but all of A. So we can say by shared angle, angle A is congruent to angle A. And now we've got two angles in both triangles, right? We've got two angles here, a purple and a right angle. And we've got two angles here, a purple and a right angle. So by double A similarity, triangle ADE is similar to triangle. Well, if A is the purple angle in the small triangle, what's the purple angle in our large triangle?
A.
Also A, they share it, right? When they share an angle, it'll always be the same. D is the unknown angle in our small triangle. It will be congruent to the angle B in the big triangle. By CSB, if you needed to get that, right? And E in the small triangle is the right angle. What's the right angle in the big triangle? C. So we got ABC. Now we're going to rearrange the parts by what? What allows us to rearrange the parts? Yep, awesome. By CSP, we can match up the things. Now if you're clever, you'll know which ones they want. I'm just going to write all of it down. Oops, that's AC. Letters are hard, guys. All right. Does everybody see how I got those? Right, corresponding parts. Corresponding parts will be similar. AD and AB are both first and second. DE and BC are second and third. AE and AC are first and third, so they're going to go together. Now we want AD and BC and AB and DE. So once again, this is what we want. I won't rewrite it. I'll just do this. I'm going to move over BC by multiplication. And I'm going to move over AB by multiplication. And when I write it, I'm going to write AB first, because that's what they had up top. And we're done. How do you like them apples? Great. I like this. Like pull back, look super tight on top. Good idea. And make sure the forehead is visible at all times.
I'm just consistently exactly this brown for everything.
Oh yes, I'm sorry. It is not okay, but I'm glad you understand.
Okay, I'm done.
Okay. Wow. It's like a mirror.
Oh my god.
No, you can use like brown.
That's black
Right.
face.
AC, BC. They're congruent. As soon as I do that, what are you thinking?
I saw some.
Boom. Like your sweater.
Thank
Also like your shirt. I think Flora Hudson has the same one.
You are
They're
yesterday.
both great shirts. Yep. If you ever wear it on the same day, you can just tell me and I will be like, Literally, go home.
Okay.
You have a cold, literally. Go home.
Okay.
I'll take care of it.
Thank you.
Call the office and be like, literally just puked in my class. She has to go home. she doesn't remember because she's like losing her consciousness. She's so sick. Send her home. All right. We want to get these sides together. And we don't even have to move them after we get them, right? AD and BF. AD and BF are those two sides of that triangle. AE and BE are those two sides. So which two triangles do I want to get similar? These two. And they're both right triangles, so we should have a pretty good chance of doing that. What do you see? Shelby.
Didn't we already say the isosceles?
Yeah. By isosceles triangle theorem, this whole side is across from this angle, right? So that angle will end up being the same as this angle by isosceles triangle theorem. Not the converse, because the theorem is when you have the sides and gets to the angles, right? Converse is the other way around. So we know that angle A is congruent to angle B, because there's only one angle A and only one angle B. So I can use the shortcut, use single letter name. It's like when I have multiple students with the same name, you have to use the full name. Only one A, only one B. Only one Courtney, only one Jerkica. So I can just call you by your first names, right? Okay, so now we have two angles, so those triangles are similar by what? Yep. Our favorite. Again, if the diagram doesn't give you anything about sides, you're not going to use any of the sides. So we know that these two triangles are the same. I'll go left triangle ADE, similar to right triangle. Ha ha ha. Right, it's a right triangle on the right side. A goes with B. D goes with F. And E goes with D. And they will be congruent by CSB, but we don't care. Now we're going to get the parts. By CSB. AD should go with BF. And DE should go with FE. And AE should go with BE. Which ones do we care about? The first and the third. And we're done.
Wow, I was so fast.
Are we feeling good?
Yeah, just like give me a second to write
Do you
this
feel
out.
secure? Okay. I can't fix everything, I guess. Dylan. Good. Keaton.
Oh, do we have to write that?
Bo. You
We
what?
have to write that it's by transitive.
I can't hear you because Courtney was coughing.
Do
What?
we have to write that it's by transitive?
No.
I already asked that.
Well, I didn't hear
Wow.
you. Holly, what even is that?
Can't hear you
I was
over your
being
loud
attacked.
forehead.
Shut up! That's so mean.
I'm back, and I am the meanest teacher.
You're bigger than yours.
Oh my god!
Yeah. Up top. All right.
I didn't
Is this
say-
cyberbullying because we're live?
Yes.
Amazing.
It's
Both cyberbullying and regular
Do you
bullying at
always
the
twin
same
with your
time.
stapler?
I said that first.
AC and BC are congruent. Are you going to write your forehead?
My forehead.
His forehead is literally
It's
twice
okay,
the
Jer.
size of Jericho's.
It's true, right?
It's
The
fine.
size of
I have a forehead on my back. All right, CD and AB are perpendicular. FE and AC are perpendicular. All right, we got Triangle City here.
Scary.
Which triangles do we care about? What?
Never mind, I was gonna
You
say-
can calm down. AE is this segment, and AC is this. Ooh. It's different this time. We care about this thing, which only belongs to this triangle, so we know we want the big laying down triangle, right? And then AC belongs to two triangles. Either this triangle here, or the big triangle, right? So we don't know which one we want out of those two. AF, nice, belongs to this triangle laying down, right? And AD belongs, well, to this guy, right? So we want this triangle here, and the triangle that's laying down. Does everybody see those two?
Shared angle.
Those are the two we want to go for.
Kayla, shut up.
Yeah, literally no one asked.
Solidarity. We got isosceles triangle theorem, which tells us we get these two, right?
I know.
Good.
Woo-hoo.
Did I ask?
I'll write sad to write on the board.
No, because
Angle A congruent. Can we call angle B angle B? No! So what do you want to call it?
wait, why not?
There's multiple angle B's.
Multiple.
My bad.
Angle
Sorry, guys.
CBA.
CBA. Decisive. All right. Do we have two angles in both our triangles? Well, it looks like we have one angle for this guy, and we got two angles for this one, right? Nope. Looks like one. We only have one, right? Where's our other angle going to come from? Go ahead.
Linear pair theorem.
Linear pair theorem. Right? We get both 90s. Now, do I need you to write that? Nope. You could have written that right from the given. I chose to put it on these sides just to make it so if you did that on accident tomorrow, you'd have a way to see it, right? So these are the two we're going to be interested in. Right? That's technically given. So we're going to allow it. If you wanted to, you could say LPT, right? If both angles are congruent, which they is, right? And they have to add up to 180, then they both must be 90. So we've got two angles now. A right angle in this triangle and a blue angle. We've got a right angle in this triangle and a blue angle. So by angle similarity, our favorite triangle, let's do the upright one first. ACD, similar to laying down triangle. A is going to go with A because they're shared, like Taylor pointed out. C is the unknown angle in our tall triangle, right, our standing up one. What's the unknown angle in our laying down? F. What's your profanity? D is the right angle. What's the right angle in the laying down triangle? E as in elephant. E as in yog. All right. So we have the two triangles. It's like dog, but with E. Right? So, like M is in Mancy. So now, by CSP, right?
Someone wrote Zach is a monkey.
Yikes.
That was Jenna.
You haven't added me back
Send
yet.
it to me.
So.
Send it to me, Shelby.
Oh no, I flipped them.
Okay. Oh, I have to add you first. I was gonna say. You have to.
AD and
You
AE.
blocked Taylor too?
All right, which ones do we care about? AE and AC. There's AE, there's AC. We also care about AF and AD, so we don't care about the middle. So we're going to write that AE, after we multiply it over, times AC equals AD times, after we multiply AF over, AF.
Yeah,
No.
I'm
Really,
you're
you're
going
going
extremely fast.
That's because the first 5 are super easy.
I know, but like, let's.
And we gotta get to the last two.
Can you just,
Let's just.
I will pause.
That's
how-
I'm fine with pausing at the end.
do you have to show like how you multiply? Because like you could literally just
Nope.
write the first down.
What do you mean?
Up there, it says
Oh, once you get here, just write it. That's true. Hopefully you have the right letters though, because some of these problems will be more complex, and you won't always just get the right letters right from the go. Gotta make sure you have the right triangles you want. But yeah, you don't need to
Wait,
show
so-
multiplication.
Is it gonna be like that on the quiz where it's a bunch of the easier ones and 2 hard ones?
Well, these are the possible problems I can give you,
I don't even know how to start.
right? Does that make sense? I'm not gonna give you a problem that's not on here,
Oh really?
but you don't have to do that.
But like I will though.
You're not gonna have one like that? You told us yesterday you would have.
I told you yesterday that it will be on a quiz.
Yeah,
The plan
Diane
right
said that.
now is to have that one on next week's quiz because we're going to use that again. We're actually going to use that theorem to prove things, right? And so you're going to have to prove that theorem on the quiz and then use it as well. Same thing with number 4 from the packet, is right? Okay. So let's look at number 6. Here we go. They tell you that D is the midpoint of AC. So here we go. That means this, right? E is the midpoint of AB.
I like this friend about it.
Go right out on the board.
We want to get BC and DE together. So BC and DE are these two sides, right? We want to relate them. And not only do we want to relate them, but we want them to be double. So we need to know some information about their sides, right, and how they relate. We also want to prove that BC and DE are parallel. So the two triangles we're interested in is this triangle and the big triangle,
Are we
right?
gonna extend the lines?
And they do share angle A. We're not going to extend the lines. By shared angle, angle A is congruent to angle A. So there's only one angle A. Right? Both the small triangle and the big triangle use angle A. Do we have enough information to prove the triangle similar? Side angle, side similarity, right?
Wait,
Again,
how does-
we need to talk about the sides before we can use SAS, but notice that this side is half of this side, right? and this side is also half of that side. So they both are proportional. They relate by the same number, half, right? If this was a third of this whole side, and this was a half, they wouldn't be proportional, right? But it's half and half, so it's okay. So we're going to say that AD over AC, again, the whole thing, relates by 1 versus 2, right? 1 versus 2. Does everybody see that relationship, 1 and 2?
Wait, why didn't we
1 red,
side
2 red.
angle side?
Why do we have to talk
We're not
about-
writing that yet because we haven't talked about the sides. We've only talked about the angle. We have to talk about the sides, and then we can say, look, 2 sides, 1 angle, side
But
angle
isn't
side.
that basically given? So like.
Yeah, essentially, yeah. So we're going to say this equals, what isn't given is that they're equal, but we're going to say that. Equals AE over AB. I've lost hearing in one of my ears. This happens right now. Like, this is not good.
Every day after lunch when I
Whenever
walk
I'm
up
in
the
my
stairs,
bathroom,
my
I
ears
hear
ring.
All right, kindergarten, I did not ask for your stories, right?
Wait, is it like an ocular migraine?
No one cares. All right, so these two relate by what? What's the ratio?
2.
Wunhave.
Well, 2.
Did you?
Now again, it's 1 over 2, not 2 over 1, because look, AD is 1 and AC is double, right? Now, could they be 3 and 6? Could they be 4 and 8? Could it be 5 and 10? Sure, but at the end of the day, what does that all reduce to? A half. And again, because I put 80 on top, 1 goes on top, right? So if you're clever, you'd be like, look, I'm just going to start out flipping those around. But I didn't. Why? Because I'm trying to show you that you can, right? So we have this. We've talked about two pairs of proportional sides, right? And we have an angle in between. So we can use side angle side now. Do you see how you have to have this first before you can use side angle side? You have to have talked about 2 sides and the angle. You can't just be like, oh, from here, side angle side. I see angles, that's all I see. Unless you mentioned it, I don't see it. Cool. So we're going to say by side angle side similarity. Triangle, let's go with the small one first. We'll go with ADE. Similar to A goes with A in the big triangle. D. Now if you notice, D is made up of the unknown side and the red side. So if we go to proportional red side and unknown side, it goes with C. E is unknown side and the blue side. So if we go to unknown side and proportional blue side, we got B. Good. We care about B, C, and D, E. So instead of writing everything, I'm just going to write by CSP.
Probably a softball there.
BC looks like it's second and third, right? So I'll write BC. That's second and third. And they wanted DE. That's also second and third. So I'm allowed to put those together. Ooh, we're going to have to use all of them. How do we know BC and DE is a half? We don't, right? So we have to use all of them. We have to use AD and AC as well. Whoops. I did BC first. Oh no. Alright, hold up guys. Hold up.
I was like, you just threw me off.
Yeah, behind
So-
it. Did it write that down yet?
There was nothing wrong with what I was doing, but I knew that you guys would get confused. So we're just going to do this. I thought we were ready to jump ahead, but I don't think we are.
No, I don't
So,
know.
Do you see how I got those by CSP?
There we go.
Okay. Now, we care about BC and DE, that's this one. There's one other thing that we're forgetting. Notice that all of these relate by what?
Half.
Half. They have to, right? Because AD and AC are a half,
Oh, well, they should
and
Therefore-
AE and AB are a half. Therefore, DE, since it's equal to them, right? DE over CB must also be a half. I don't know if you guys saw this, but that's the red thing from before, and that's the blue thing from before, right?
Wait, what?
Are you with me?
Oh,
Why'd you
it's
circle
up there.
those?
Right. You see how that's the red and the blue from before?
Yeah.
So if those are both a half and they're equal to this, then this must also be a half, right?
Colors mean nothing to me.
Duh.
Yikes. Okay, so that's a half. Now they wanted it to equal 2.
Flip it.
We just got to flip it, so we're going to write that therefore, and you can use the therefore symbol if you want, CB over DE equals 2 over 1, which of course equals 2.
That wasn't too bad.
Right? Again, it depends on which way you're going. Are you going from small to big? Then it's half. Are you going from big to small? It's double.
How did you prove the parallel one?
So that's the next thing we got to do. We're not done. We're done with that part. We got to prove that BC and DE are parallel.
I thought that was
So
given
wait.
away.
How did we know it was
Oh,
one
okay.
again?
See how these were a half from earlier?
Yeah.
and see how this is equal to those. So this must also be a half. Right, if the triangles are similar, all their parts are going to relate by the same thing. So if that's half of the whole thing and that's half of the whole thing, this is going to be half of the whole thing. Right? You smell them stepping in there, Hannah?
Yeah.
Okay. Yeah.
I see it.
If you use cap to prove that B and E are congruent and D and C are congruent, then do you know that they're parallel? Because they both have the same angle.
So what we're going to do is we're going to prove that this angle here and that angle there are the same. Not by cap, because cap requires parallel lines.
So
Okay.
we just prove.
Right? We know the triangles are similar, right? Similar triangles have proportional sides, right? In this case, it's by a half. And they have what with their angles? Same angles, congruent, right? Their angles are congruent. So we're going to use CSP to get the angles as well. So also by CSP, we know that angle, what angle were we interested in? Angle D, right? Let's call it angle ADE. If you look, angle ADE, first, second, third. Does everybody see where I'm getting first, second, third here? Right? Angle ADE should be congruent to angle ACB. First, second, third.
Wait, can you re-explain that, please?
Yep, so look, ADE is first, second, third here. And that's the angle I'm interested in, right? And this is also first, second, third. So by CSP, they should be the same, right? So this angle, ADE, should be the same as ACB. ACB is this angle. Now, could I do that for the other set of angles? Yes. That's angle AED, right? And if you look, AED is first, third, second. That should be congruent first, third, second over here. First, third, second is ABC, angle ABC. Now, I'm not going to do that because I don't need another set of angles to prove these are parallel. Because if you look, I've got cap converse. Remember, cap says if the lines are parallel, then corresponding angles are congruent, right? But cap converse says if corresponding angles are congruent, the lines must be parallel. So we're going to use cap converse. I am glad that some of you have arrived where the rest of my classes are as well. That is good. By cap converse, it was.
Okay, what?
We know that DE must be parallel.
You know what? I was in a good mood, and then you just took it away. So,
Are you still sad about your forehead?
no, I'm sad that you've attacked us all day. Specifically.
Us or you?
Yeah. Poor
Right?
Jericho. Thank you, Shelby.
You can attack me.
That's right. We already asked about Bailey's nanny.
I don't get that part.
Bailey's
Cap
nanny?
con.
I don't understand.
No. No.
with
Yeah,
you.
I don't get it either. But I don't
Team
get
Bailey.
the cap converse part.
Okay, so isn't it true that if we have two parallel lines
I could go there for the night.
and they're cut by a transversal, that corresponding angles will be congruent?
Mm-hmm.
Cap converse says if we have corresponding angles congruent, and they are corresponding top left corner, right? Then the lines must be parallel. So it works in reverse, kind of like isosceles triangle theorem and its converse, right? The theorem is sides get us the angles. The converse is angles get us the sides, right? For this, the parallels get us the angles. The converse is the angles get us the parallels. So it's just cap in reverse. If the angles are the same, then the lines must be parallel. Shelby, did that help?
Yes.
Okay.
I wrote it down.
I just wanted to make sure that it helped because I feel like I answered your question about halfway through my explanation. You don't have.
No, I listened. I even wrote it down.
Okay.
And
No,
wrote an
that's fine. I don't care whether you
explanation
wrote it down or whatever. I just want to make sure it helped.
Mhm.
Okay. Good. Good. How do we feel about cap converse?
A little over.
Angles get you the parallels. Okay.
about it. No.
Wait,
Why
can
do
I
we
get
have
the
to
last
fall
part?
back?
Wait, I don't know if I got the last part.
Like understood, you mean? Or need to write down?
I got it.
Okay.
I got it though. I just-
It's P-tag time.
I don't even remember how to do that. It's okay.
She's not having back.
Red, orange, green, purple, pink.
Are we good, Bailey, or do we need to wait for you to name all the colors?
Right? Orange, yellow, green, blue,
Chartreuse.
indigo, violet.
You get it.
That's it.
All right, here we go.
What you did.
We're told that this angle and this angle are 90. And by extension, I also get this one, right? By LPT. Here's what we're going to do. We're going to prove P-tag. We're going to get all three triangles similar, right? Nolan? Buckle up.
I can't go too
fast. You can't run.
Small and medium are going to relate. Medium and large are going to relate. Small and large will relate. Now, logic says that the reason we call them small, medium, and large is because small is smaller than medium. And medium is smaller than the large. So if imagine that the medium is double the small, right? And imagine the large is double the medium. Is the large going to be double the small? No, it'll be 4 times as big, right? So they're all going to be similar, but not in the same way, right? It's like you're all special, or you're all unique in the same way, right? All of you are unique, right? So small might be half of the medium might be half of the large. That would make small a quarter of the large, right? So they're all going to be proportional, but it's not all going to be the same way. So we can't just go small, medium, large all together. What we're going to have to do is do small, medium together, medium, large together, small, and medium together. So we're going to get all 3 pairs together. So here's what we're going to do. Small and the biggest first. Do you see anything? Small, big. Shared angle, they share A, don't they?
That's not the angle I was thinking.
That's not.
They both have a 90, but they don't share it. They overlap, Bailey. That's what a shared angle is. See how they both use angle A?
Yeah.
Right? They don't both use that angle there.
I wasn't talking about that.
What were you talking about, this one? Or?
Yeah. But that's just because I didn't.
So this one isn't the whole thing, right?
Yeah,
That's
yeah,
why. Okay.
no.
Good. I just want to
That's
make
what I
sure.
was gonna say.
It doesn't use the whole thing, so it doesn't count. It
Yeah.
has to be perfect overlap. So angle A is congruent to angle A. Therefore, by angle similarity, the small triangle, I'm going to put an S in here just so I know what I'm talking about. I'll call it ACD, must be similar to the large triangle. Now, the small triangle, angle A, is purple. What's the purple angle in the large triangle?
A.
Also A, right? They share it. Large, not medium, right? We're clear. Small, medium, large, right? C in the small triangle is this unknown angle down here, right? What's the angle we don't know about in the large triangle? B. And so by CSP, they will be the same. D is the 90 in the small triangle. What's the 90? Good. C. Let's get these last angles together. So let's do by CSP angle D, or I'm sorry, angle C in the small triangle, which is this. We can't call it C, obviously. I'm going to call it angle ACD. Must be congruent to what other angle? Angle UCSP. ACD should be congruent to ABC. Could you call it B? Sure. I'm going to use the letters straight up because they're first, second, third, right? So now we've got this. Awesome. Now let's get medium and large together. So here's medium. Here's large. Medium has a green and a right angle. Does the large have a green and a right angle?
Yes.
It does. Green and right angle. So by AA, they must be similar. Medium. Medium I will call BCD. And it's similar to the large.
Can you screw this?
Oh, yes. Yes. And the large, if I call it BCD down here, B is the green angle. What's the green angle in the large triangle? The large triangle.
B.
It's the green angle in the small. The green angle in the big is B. The only 3 angles that we're looking at for the big are these 3, right? So it's going to be B. C in the medium triangle is this angle down here that we don't know about. Well, it's not the right angle, and it's not the green angle. What angle must it be on the large triangle? It must, it's not the green angle, it's not the right angle, it must be the purple angle, right? Well, here's our big triangle. It has a green angle, a right angle, and a purple angle. This one has a green angle, a right angle, and the angle we don't know about. So that angle, since these triangles are similar, that angle should be a purple angle. It should be the same here. Are you with me on there, Shelby? Right? Because if they're similar, which we said they have to be, then all of their angles should have a pair, right? They should match up with something. So if that matches with the green, right, for both, and if that matches with the right angle, then this angle here must match with the purple. So it's going to go with A. D is the right angle. What's the right angle in our big triangle? C. Lastly, by CSP, we'll say what we said earlier. this angle here, angle BCD, should be purple, right? It should match up with, BCD should match up with angle what? BAC, right? Okay, cool. Awesome, awesome, awesome. So we've related all the triangles, right? Wrong. What other pair am I missing? Small and medium. I'm not going to worry about those. Could you do it? Sure. But we're not going to end up using it. I'll show you why. By CSP, what part should match up over here? AC and AB, CD and AD and good. Over here,
How do you go so fast?
BC and good job, guitar. CD and BD and we'll pause for station identification.
Wait,
Yeah,
does that
What if we just like
does by AA go with BCD and A or B?
Ooh, yes, yes, yes. By angle similarity
Okay.
for both. Yep. Right, both of these were by angle similarity.
Wait, why did you?
Yeah, you already said that.
Yeah, we already.
There's not
Oh, did I? Oh, what's my bad?
But this wasn't in the
Yeah,
like,
yeah, my
box
dash
and-
was
yeah.
different. Sorry.
That's why I was confused.
Sorry. Does everybody have these now?
No.
No.
Okay, we'll write them down. We're focusing over here. We're going to switch out those letters for their little letters. Okay? So I'm going to do that and you're going to trust me on it.
Oh, I hate this part.
So these guys for the little letters. AC is what little letter? B, little b. Little b. AB, AB is what little letter?
C.
C.
I can't. Can you more red?
All right, then I'm just going to write it down.
Like
Chase's.
What is CD in your diagram? Good.
G.
BC is A. AD is F. AC is B. Now, what do you notice about this one?
Two B's.
We're going to need a double B. All right, so see this? See how AC is the same thing as little b? I did that for all the things. That's it. Thank you for asking. Again, the problem is small, causing an issue this big. Right? Next one, BC is what on your diagram? Bailey, what's BC? A, little a. And BA is little c. It's also E plus F, right? But we're going to go with little c. CD is good. AC is B. BD is A. And BC, oh wait, hold on. BD is E, and BC is A. My bad. Cool. Now what do you know about this one? There's two A's. So is it true that if I put my finger here, can I multiply the B over?
Yeah.
And multiply the C over? So what this implies is that B squared equals C times F. And what this implies, if I put my finger here, because again I can cut out the middleman, right? A squared must equal what?
A squared.
C times E.
C times E. All right, well we want A squared plus B squared, so let's make that happen. I'm going to take A squared and B squared and add them together. I don't know what they equal, but I do know what they equal individually, right? What does A squared equal?
C times E.
C times E. And what does B squared equal?
C times F.
So it should be true to say that A squared plus B squared equals C times E plus C times F, right? Now, last move, you got to pull out the C, which is a valid strategy. Right? Now, when we pull it out, make sure that if you put it back in, you get the same thing, right? So, if we put it back in, C times E is C times E plus C times F, right? Checks out. There should not be two C's here. There's no C squared there.
Wow.
Now, the problem is you want C squared. But Bailey, what is E plus F on our diagram? It's C, isn't it? So by substitution, we have C times C, which of course means what? What's C times C?
C squared.
C squared.
Funny how that worked out.
They're not funny.
Does the 1C just
Very
like,
serious.
disappear though?
The what?
Yeah, what happened to the F actually?
So E plus F, look in your diagram.
No, above.
Yeah, we
What
have
is E
to-
plus F, Jericho? It's C.
Oh,
No, like go back down.
there it is.
First line of that stuff.
This stuff?
Yeah, we have 2 C's.
So notice, so I think it's easier to see it backwards. C times E plus C times F, right, when we distribute? You know what I'm talking about?
It's like
Distributive property. Right? C times E plus C times F.
it's like
This is
foil.
just distribution in reverse.
Oh.
Okay? We call it pulling out.
It's foil.
It's not FOIL. FOIL's dumb because it says first, outer, inner, last. But what happens if you have three terms?
I can't
There's no first, outer, and inner, last.
Why are
You know what you're
you
doing?
so against
You're
it?
distributing. That's all you're doing. There's no need for another name.
I like the face.
Yeah, that's fine. But like, there's no need for another name for it. Why make it more confusing for students when you go, hey, you know distribution? It's the same thing. If I had, so let me rant about distribution for a second. Check it out. Your teacher would say FOIL, and that's fine. They're not wrong. Good, wonderful. If I had a 2 here, wouldn't you distribute the 2 like this?
Yeah.
Yes.
Okay, well, if there was an x here only, wouldn't you distribute the x as well?
Yeah.
Right? X times x plus 5?
Big 17.
Right, wouldn't you distribute the x?
On sides.
So you just distribute both. You don't need a first, outer, inner, last. It's just distribute the 2, distribute the x, just like you would with any number. Now, the reason I don't like FOIL is because what if you have something like this?
Oh, I get the, okay.
Right.
No.
I didn't have-
You just distribute the 3, then you distribute the y, then you distribute the x. That's it. And you write all that down. You don't need a special thing. It's distribution. Pretend the others don't exist. That's it. But instead we're like, let's invent a trick to help students remember. That's wonderful. The 13. Yeah, a lot of you are missing the 13th. I'm not sure why. If you have it, get it to me. Good luck in your quiz tomorrow. You can do this. You will be gods when you graduate this class.
No, Taylor, just leave it.
You're so upset.
Autumn. How's it going? Rough. Rough, okay. Shannon, can I help?
I have work like all week.
Okay, so what can I do to help with that? Is work just what's awful?
Work and my cousin committed suicide, so my family's kind of.
Right, from last week, yeah, so,
My parents went out my ass and now she's
that's awful. That really sucks for a lot of reasons. I didn't know this was your cousin. Sorry, Autumn, are you hanging in there? Are you gonna be okay? I know you're not, but are you going to be?
Yeah.
Promise. Okay, if you ever feel like you want